Hello, welcome to this video. It will all be a voiceover because I accidentally recorded music instead of my actual voice while recording this. Anyways, I'm going to teach you how to do recursion in F# or functional programming. Recursion with accumulators and recursion with continuation and just normal recursion. As you can see here in the green comments, I have made an example of a normal loop which returned all the elements in a list together. Given that all the elements in the list is integers. As you can see down here, this is one way of making a list in F#, and as before, everything is expression, so list 1 is now this list. And it's very important to note that in F# things are immutable, which means they can't be changed. Now the list 1 exists of 1, 2, 3, 4, then we can't just say list 1.add. We need to make a new list to change it. And list 2 is an example of an empty list. Now let's do the recursion. First of all, we make it a recursive function by making it rec in the start. Then we say the name of the function, and then the list we are receiving. Then we match this list, because you match an F#, and LST is the list we're going to receive. And we're gonna iterate through this list, so it will either have elements in it or not have any elements in it. So if it has 0 elements in it, we are done. And we are going to add all the numbers in this list together. Now, this is how we write the list. X is the first element in the list, and XS is the tail of the list, so the rest of the list. So when we iterate through it first, it will be the element 1 that will be X. Head and tail. That is how we differentiated it. Let me just wait for past me writing this down in the comments so we can get on to the actual recursion, what happens here. So we are going to make a list which are taking numbers and adding them together. So we will write X. X is the first number in the list. And then we're gonna add it together with the rest. But now it's the tail we need to go through, and this is where we start the recursion. Because normally you just loop through it, as you can see up there in the comment, but instead we are going to take the function we are literally in and call it again, as you can see here. So we are taking the numbers, and as seen before, we have LST, but now we have a new list, XS, which is only the tail. So we put the tail into the function, and this is where the recursion happens. This means that when you run this, X will first be 1 plus the rest, then it will be 1 plus 2 plus the rest, then it will be 1 plus 2 plus 3 plus the rest. And as we can see, we get the right number. That is good. And if we have a 0, it would hopefully be 0, because that is our edge case. If there's no elements in the list, we print 0. And now, just to visualize how this actually works and how F# actually analyzes this function, this is how I write it. The head is 1, as you can see, and then we plus it, and then we take parentheses the rest of the function, which will be add number XS, and then we go into the function again, and then it will be 2, because we have already analyzed the first element and thrown it out. Then we get to 2, and then we get to 3, and then to 4, and then we will add with 0, because the list will be empty, and then we will traverse backwards. So it will be 4 plus 0, then it will be 3 plus 4, which is 7, and then it will be 2 plus 7, which will be 9, and then will be 1 plus 9. But now we're gonna do tail recursion with accumulator, which instead of terminating the function afterwards and doing the arithmetic after we have run the function, we do it while we run the function. But first of all, let's just write it up. So you actually do kind of the same, except we have a helper function, because we now have an accumulator, and the accumulator is actually the thing we are returning and will be the final number in our function. And what I'm doing here is I'm calling a function inside a function, so we can call the add numbers accumulator the exact same way we called the add numbers function. Then we match it like before, and we have both list prime and accumulator. So we match list with an empty list, and if the list is empty, we want to return our accumulator, because at this point our accumulator will have calculated whatever we need to calculate, and it will be the final number. Now for the recursive functionality, we need to take the head and the tail, x and xs, like before. And don't mind what I'm marking, because this is a voiceover. Again, I'm sorry, I can remember exactly why I marked this and that. But we're gonna call the helper function, and we can call that again because we made it a recursive function with the rec, the rec. Now we call it with both xs and accumulator, and xs is the tail, and now accumulator. Helper takes xs, which will be the tail, but now we need to make the accumulator actually make the arithmetic option. But instead of just saying x plus accumulator, we put it in a parentheses. This means the accumulator will automatically get updated. But as you can see, there's still a fail, because we never call this function, it's just exists. It's unfinished. So therefore we need to call the helper function. And here we call the accumulator will be our base case. So if this list is empty, it will be 0. And I'm probably explained this much better when I made this video. This was like half a year ago. I'm sorry. Yeah, and this works the exact same way, except it's better. And future color here, it's better because it's faster. The computer is faster to calculate the accumulator because it's calculated live instead of by the end. So that's why it's better. It's much more efficient. And as you can see, this is how the accumulator will calculate the function. First it will say 1 plus 2, that's 3, then it has 3 in the accumulator, then it adds 3 to 4 in the accumulator, and then it will get 0 and say 4 plus 0. So yeah, I know I wrote it a little bit weird there, but I hope you can follow along. Now for the last part, we will do tail recursion with continuation, which works similar to accumulators, with accumulator, but instead of having an accumulator, we actually have functions that act like an accumulator, which means instead of terminating arithmetic option, it is functions. So it's a function that takes a previous function and receives a function. And just like before, we need an accumulator, but we're actually gonna call it something else. I will edit it, but it's very good to start with the accumulator base case because they are similar. So as you can see here, I'm making an anonymous function, fun res, that is the res, I can't remember what res is, but it's basically what we're gonna return as our accumulator. So we make an anonymous function, we call. Alright, and we are back to the actually continuation. It's result, that's what res stands for. Great. So this will be the result, and it will be a bunch of functions anonymously counting each other. So count is actually going to be our accumulator, which I will change in a second. Look at that. And now count will not be a number, it will be a function, because you'll see in a minute. And that is the way we call it. And yeah, right now it does not recognize count as a function, but it will in a minute. Now I see, yes. So we take x, we still need to do the arithmetic option. So we say x plus the result, because the result will be the previous result, and that way it will, yeah. Yes, I'm sorry, it's been a while, but I'm not sure why I don't make it a plus. Okay, ID is basically just saying x to x, so it's the same as, please say I'm gonna show it, but it's the baseline. It is also the same as just saying fun x to x. Yeah, so it's a way of whatever you give it is itself. So that's the same as ID. That's just a shortcut in functional programming. Pretty sure I do a mistake here in a bit if I try to run this. Yep, because I did not plus it. I did not make any arithmetic options. So we'll see that in a minute. I'm pretty sure we all make mistakes. Fun fact, I actually made this video like 1 day before my exam, and some of the stuff I did in this video, or like also stuff I was just messing around with, really helped me, and I could use it in the exam, so that was just epic. I felt so smart, and I actually passed my exam. First time around, I did not pass my exam, and let's see that we will have an error. I'm pretty sure we will. This is the continuation. List 1. Let's see. Yeah, what did I tell you guys? What did I tell you guys? Now, let's go back and analyze what actually went wrong. I'm pretty sure it's because I never plus it, but it's possible there are other mistakes as well, because we call the helper function, and we do give it a continuation, a function. So here I'm going through. A good way to actually see where you have stuff wrong is to typecast. This is typecasting. I'm just saying this list is an integer list, and now down here I can see, oh, it did not express list prime to be a integer list. Now I make that a list, into list. Now I can see the result doesn't make any sense, and then I will probably in a minute figure out why, because we don't do any arithmetic operation here. Let's see that plus. What did I tell you guys? What did I tell you guys? Am I just smart or what? And now I'm probably just explain more about that fucking... Oh, sorry. About that typecasting stuff. Let's see. Let's see if it works. I think it will work, but you never know. You never know. Let's see. Well, it sure as hell does look weird. Now, I have no clue why it does this. Let's see what past me figured out. Past me figured out that we want to return an int, and then we realized that we do not return an int, because the helper list does not return an int. And why does the helper list not return an int? Because the continuation does not end up as an int, even though we does do arithmetic operation. So what is it we need to change? It is an integer. Not sure. I'm doing this. We need to give it a base case. That was the mistake. So, whenever we reach empty, we just give the function 0. So, if we give an empty list, it will immediately just return 0. I'm sorry this does not make more sense, and it's like half a year ago I took the course of functional programming. I could have explained it a lot more there, but I got, I procrastinated making this video because the voice was cut out. So that was just amazing. And yet again, we have mistakes. And I'm pretty sure that's just because I didn't take it all. There you go. If you use F# interactive and don't send it all, but like halfway through a function, it would be like, this is not a function because you obviously didn't take the function. And there we have it. We finally have a working continuation. And hopefully I'll draw it. But it works like accumulators, but instead of taking a number, it's a function, and it keeps taking the previous function and calculating. And in some cases, doing continuation is better than doing accumulators, but I can't remember when that will be an issue. So you're just gonna have to Google it yourself. And also, I hope you can understand what I've been saying. I have the tendency to mumble a bit when I speak English, and also, yeah, a teeny tiny lisp sometimes. Anyways, I think this is about to be the end of the video. Hopefully you learned something. I for sure did. I learned that I'm still suck at doing continuations. It's been very hard for me to do, but a good way is always to look at examples and figure out how they are like. And now I'm doing something with a pizza, and I'm not sure what this is about. I think I did a test. This is my testing, where I did something with the recursive. I was challenging myself, making a pizza, and the video ended. There's no more. I don't know what that is. Anyways, Goodbye.